Alright, hello, I'm Steve. Today I'm going to be talking a little bit about asteroid belts, the history of the moon, the history of young Earth, and also some orbits. That's pretty much just like an overview of what I'm going to do. I'm going to be answering questions about each section, and yeah, let's get started. So, the first question is, how do we explain the asteroid belts, Main and Kuiper? The main asteroid belt orbits between Mars and Jupiter. This belt is estimated to consist of millions of objects, one being Ceres, the biggest comet, so big that it's considered a dwarf planet. And the Kuiper asteroid belt is the outer main belt. It's like right outside the solar system. And this belt is estimated to consist of hundreds of thousands of asteroids, and it's thought to be contain more icy objects. Question 2 is, what was the period of the heavy bombardment? It's a theory that the Earth and the entire inner solar system suffered through an intense spike of asteroid bombardments roughly 4 billion years ago. The next question is, how might the composition of Earth's early atmosphere be in part attributed to this period of heavy bombardment? Early Earth's air weighed less than half of today's atmosphere, and this less dense atmosphere allowed tons of meteors to strike the Earth. Those meteorites contained water along with hydrogen compounds, which allowed the Earth to collect all the water it has today. The next question I have is, what's the difference between an asteroid and a comet? Well, asteroids are rocky and comets are icy. And what's a meteoroid? A meteoroid is a small body moving the solar system. The next question, what is a meteor? A meteor is a small body of matter from outer space that enters the Earth's atmosphere, lighting up as a result of friction. And what is a meteorite? A meteorite is a part of a meteor that survives the Earth's atmosphere and strikes the ground. The next question I have is, describe the differences in density of the Earth and Moon. Given what we know of the frost line, what does this imply about their formation of the early solar system? So the Moon has a considerably lower density than Earth. The Moon's overall composition is very similar to Earth's outer layers, which supports the Moon being developed from a giant impact into the young Earth. Next question is, what is the difference between a unbound hyperbolic, unbound parabolic, and capture-bound orbits? So an unbound hyperbolic orbit is a trajectory of any object around a central body with more than enough speed to escape the central object's gravity. And unbound parabolics are orbits that open with an eccentricity of exactly 1, and this means that the object will never return. And it's pretty much like an unbound hyperbolic, but it's specifically has the eccentricity of exactly 1. And a capture bound orbit is a round, which means the object will return to its starting point after a full period. As you can see in like the pictures, you have the bound elliptical orbit, and then you have the unbound parabolic orbit, and then you have the unbound hyperbolic orbit. Next question, question 3 for this section is it possible that the Moon was captured by the gravitational well of the Earth? What other explanations might make sense? My answer is yes or no. Our Moon now, to begin with, would be way too large for Earth's gravity to catch it, but who's to say the Moon was fully formed before it got to the Earth? It could have been smaller and got caught in Earth's orbit and form alongside the Earth into the Moon we know today. So that's one theory. The other explanation is a giant impact between the young Earth and a giant planetesimal. You can see the Earth is getting smashed up by a big planetesimal. Pretty much how, to kind of summarize it from what I know, when the planetesimal hit the young Earth, the impact caused an explosion, sending parts of the Earth into out into space, and Earth's gravity captured all those objects and kept it around its orbit, and those objects in that orbit eventually combined into the Moon we know now. For the next question is, compare the composition of the outer layers of the Moon to the outer layers of the Earth, and what general observations could you make? So in this slide you can see on the bottom left, the Earth and Moon's outer layers are quite similar. The Earth and Moon share many similarities, which points to showing that the Moon is made up of parts of the Earth from the giant impact. Final question. Given the observation of the upper surface composition of the Earth and Moon, and the fact that the Earth is the only terrestrial planet to have a relatively large moon, what reason might this explain this anomaly? So, to explain this anomaly, the giant impact caused the Earth to blast materials into Earth's orbit, later forming into the Moon that we know today. So that's how we could explain how the Moon, or how we captured this large of a moon in our orbit. So, yep, that's my slides. That's all my questions, and yeah.